Hello everyone, welcome to the live class. So guys, today in this session I am going to discuss some of the very important points, and I hope that after this session you will have idea about very important concepts, tricks and even the important and the most expected questions for your upcoming CSIR net physics exam. So we are just going to start the discussion with some of the very important points. So first topic which I will consider here, that's gonna be the Fourier transform. Clear? So if we are having various functions given to us and we want to find the Fourier transform of those functions, sometimes you may even get a question in this way, that whether it is possible for you to find the Fourier transform of all these functions, or is there any function for which you can't find the Fourier transform? So let's try to consider this question initially, and I will let you know the trick that how you can easily check whether it is possible to find the Fourier transform of the given function or not. Okay. Guys, yes, this session even I have just planned almost 10 minutes before, okay, and that's why it was not a pre-planned, okay, and if you have got to know about it just now, that's okay. Just stay connected on the Telegram channel Mission Net Physics Exam as well, so that you will not miss these notifications about the sessions. Here now I'm going to give you 4 options. So option number A, that's gonna be e to the power minus mod x, okay, and option number B we are having, that's gonna be x e to the power minus x square. Option C is e to the power x square. Option D is e to the power minus x square. Clear? Now we need to check whether for all these functions we can find the Fourier transform, or is there any function for which we can't find the Fourier transform. Clear? So check it once, and according to you, you can give me the answer in the comments right now, and I will let you know exactly what is the right option and how you can find it anytime. So once you will get it done, please let me know in the comments that which option is correct according to you. And if you don't know the concept, don't worry about it, because I will let you know about that. Very good, Subramanyam. Sahil, right now I am considering this concept from the Fourier transform. Just only one answer till now, guys. What about others? For which of the following functions we can't write, or the Fourier transform will not exist? You can get the question in this way as well. Clear? So only one answer till now. What about others? If you know the answer or whatever option is correct according to you, you can mention it in the comments. And if you don't know, don't worry, I will let you know about that. Very good, Pradeep. Very good, Sahil. What about others? Because there are many other students present in the class right now. So if you know the answer, you can mention it. And if you don't know, let's just start the discussion then. Clear? So let's talk about it. Basically, guys, if you want to know whether for any given function the Fourier transform is existing or not, what you need to do, just check that at plus infinity and minus infinity, whether the value of that function is finite or it should be 0. That means if other than finite and 0 you are getting some other value, if it is infinity, the Fourier transform of that function will not exist. Okay, so let's check for option A. If I am going to consider e to the power minus infinity here, I just need to check the value at plus infinity or minus infinity. Okay, I will get 1 upon e to the power infinity, which means what? 1 upon infinity, which means what? It is 0. That means we can write the Fourier transform of the first option, okay, or the function which is present in option A. If we are going to consider, okay, option B, clear? Here, if we are going to find the infinity, at infinity if we will try to find this value, we will get what? e to the power minus infinity square will be there. Okay, you will write 1 upon infinity, and again the x is present here, due to which when you are going to consider it, you will get infinity at this place. But sorry, it's gonna be infinity upon infinity square, or just take 1 upon infinity, which will be 0. So that means for this one even you can write the Fourier transform. Clear? So another one, if we are considering this case, e to the power infinity square, which means what? E to the power infinity, which means infinity. This condition is the condition which is telling us that we can't write the Fourier transform for this particular function. Okay, hence it is the right option, that is option C. So you just need to apply the limit on x, check it for plus minus infinity for that given function. If you are getting 0 or finite value, that means you can find its Fourier transform and it will exist. If you can't find it, if you are getting infinity, that means you can't find the Fourier transform of that given function. Is this clear till this point? Is this clear? Done? Rajesh, you have mentioned option C and option B both, but the right answer will be option C. Okay, now this is going to be very simple concept, so just by applying it you will be able to get the right answer very easily. Pradeep, you have mentioned A2. No, A is not correct. Only option C will be correct. If there is any doubt anybody is having, you can mention it. We'll consider that point. Clear? Now, along with these points, guys, I'm going to consider some of the properties of Fourier transform. So let me know how many of you are having a good command on Fourier transform, or do you want me to consider that topic once here, that what is going to be the main formula, what are the properties of Fourier transform which we can use to solve the questions based on the Fourier transform. Done? That's very good. Clear? So let's consider this topic today, and in our upcoming sessions we will even consider other topics one by one, and Fourier transform is one of the topics from where there are great chances that you can expect the questions in your upcoming exam, and it's very simple and easy as well. Why? Because if we are going to look at the questions from this topic, they are going to be direct formula based, and sometimes we are just going to get like a simple expression, just function of x will be given and we need to find its Fourier transform, so which is going to be quite easy to consider. Okay, if any function is given to you and you want to find its Fourier transform, what you will do? You just need to use the main formula, that is Pradeep. Okay, just a second guys, I'm just going to check your comments. Negative sign. Is that clear, Pradeep, now? All the options of previous question. Subramaniam, I will consider that topic too. Is that clear now? If there will be any doubt, you can mention it in the comments. We'll consider. Done? Now, so anytime if any function fx is given to you and you want to find its Fourier transform, what you need to do? The first thing you all should know, that is the formula, the main formula, which is 1 upon root 2 pi integration minus infinity to plus infinity e to the power iota sx dx. Clear? Now fx will also be there. So iota sx, fx and dx. Clear? This is how you can find the Fourier transform for any given function very easily. But the point is, here sometimes at some of the places or in some of the books you will get 1 upon 2 pi mentioned in the starting instead of 1 upon root 2 pi. Guys, generally in the BSc and MSc we are going to consider 1 upon root 2 pi. So in our exam, if they have not mentioned anything or they have not mentioned the formula, because most of the times they give the formula, even they remove this constant term and they just take 1 in place of 1 upon root 2 pi and 1 upon 2 pi. So if it is not given, what you need to do? You just need to consider 1 upon root 2 pi. Okay? Or you can do one more thing, that is you can observe the options, because both are correct. But normally in engineering we consider 1 upon 2 pi, but in MSc and BSc we consider 1 upon root 2 pi. Okay, so there is a difference between both, but both are correct, any one you can consider. And if any time any formula is already mentioned in the question, you have to consider that particular formula. Okay, and rest of the things will remain same. Another important point, like when we talk about the Laplace transform, we consider the limits 0 to infinity. Okay, but in the Fourier transform, it's gonna be minus infinity to plus infinity. So another very important point you all should consider. S, guys, S is just a positive value in general we consider. Clear? S we consider just a value greater than 0, and even you will not have to write the values of S anywhere. Okay, you can answer just by taking S itself. So don't worry about that. Now, this is the formula for the Fourier transform of any given function fx. Okay. Kirti, we have just started the discussion. The first point I have considered that if any function is given to us and we want to know whether we can write the Fourier transform of that given function or whether it exists or not, how you will check it out. Clear? Another point I have considered, if you want to find the Fourier transform for any given function, how you will find it. So this is the main formula. Now I'm just going to consider some more properties of Fourier transform which will make the things simple and easy for you. Anytime if you want to find the Fourier transform of the first order derivative of any given function, let's say df by dx. Okay, this is the symbol, the capital F I am considering for the Fourier transform and the small f I am taking for just a normal function. Clear? So in this case, you all should know that directly you can write the expression that will be equal to minus iota s fs. Okay, so directly you can consider it. You will not have to solve it completely by taking this formula and then get the answer. No, in the exam the time is very important. Okay, so we all should try to save it wherever it is possible, and this is also one of the places where you can save your time. One more thing, what is this fs? So let me just tell you the answer of the Fourier transform of any given function which you are finding, that will be fs. You can even write it with the capital F or a small f. Okay, and that's how you can write the answer for the first order derivative of any given function's Fourier transform, that will be equal to minus iota s fs. Even if you are having the nth order derivative given to you, that means dnf upon dx to the power n. Clear? So what will be the answer in this case? You can write it in general, that will be equal to minus iota s to the whole power n and fs. So directly you will be able to write this answer. Clear? Any doubt anybody is having till this point? If yes, please let me know. If no, that's good. Pradeep, just a second. I am going to check your comments just now. Pradeep, s is just a value. You will not have to put its value anytime. Clear? It's just a constant you can consider, or anything. S can have any value. Generally we consider s is greater than 0 in most of the cases. Okay, but here you will not have to put its value, so don't worry about s too much. And even before this I have answered your question. Done. So answers will be in terms of s. You will not have to put the value of s, so don't worry about the values of s. Clear? CK lectures, we will consider it. See guys, basically the Fourier transform generally we even use in quantum mechanics to convert one phase space, or let's say anytime you are having any function given in the x space. Clear? That means position space, and you want to convert it into the momentum space, you can use the Fourier transform or inverse Fourier transform. So by using the Fourier and the inverse Fourier transform, we can convert the one space wave function to the another space. So that's how we use the Fourier transform in any of the cases. But in mathematical physics it is a direct topic, so we can expect the direct questions based on it. Okay, very good Meenakshi, the same thing as I have mentioned. So that is how we can use it. Next property guys, that is gonna be the change of scale property. If any time you know the Fourier transform of any given function fx, let's say that is equal to fs. Don't get confused in this fs or this fs. You can write it in any way. Fs means just one function of s. Okay, another thing, if we want to find the Fourier transform of fax, clear, that you can directly write. If you know this, then you can directly write the function of ax Fourier transform, that will be equal to 1 upon a f s upon a. Okay, you will not have to solve it again and again. Even if it is given to you, you can directly solve it and you can get the answer. Done? Any doubt till this point? If yes, you can mention it in the comments now. I'm just going to check your comments. Done? Let's talk about the next property. If we are going to talk about the another one, guys, if any time you are going to find the Fourier transform of any given function, okay, and there you are having this expression present, that is minus infinity to plus infinity integration is there, and this identity is also known as the Parseval identity. Clear? And according to this, we are going to have integration from minus infinity to plus infinity fx, and if you are having the modulus of this, clear, and it's a square and dx is present here, then what you can do, you can simplify it in this way, that is directly you can write its answer, that will be minus infinity to plus infinity fs and mod square and ds. So both will be equal. If you know any one of them, you can directly get the other one. Okay, because sometimes it can be the case that one value they are giving you in the question and the other one you need to find. Okay, so it will be easy for you to consider it if you know this property. Next thing, if we are going to consider the Fourier transform of Dirac delta function, can you please let me know, if we are going to find the Fourier transform of delta x, what will be the value you will get? Here is the main formula of Fourier transform. Just try to find it out and let me know what will be your final answer for the Fourier transform of Dirac delta function. Yeah, Subramaniam, we can even use t and omega or k, and like the symbols can get changed. Instead of s, you may even have the k present there. Done. So symbols can be like different in different books. And let me know once you will get the Fourier transform of Dirac delta function. Delta x. Very good, Subramaniam. Yes, Sai. What about others, guys? What will be the Fourier transform of Dirac delta function? See, here if we are considering the main formula as 1 upon root 2 pi, okay, with 1 upon root 2 pi, which is the general formula. Clear? If you will consider it in this way, let's write it here. 1 upon root 2 pi integration from minus infinity to plus infinity e to the power iota sx del x and dx. As per the property of Dirac delta function, we all know that integration minus infinity to plus infinity fx del x dx will be equal to what? f0. Why? Because here I have taken delta x minus 0. Done. Or in general, if I am writing minus infinity to plus infinity fx delta x minus a, in this case what will happen? I will just equate it with 0. I will get x is equal to a here, and after getting it, I am just going to replace this fx. That means in place of x, I will put the value a. There is another property, even in the same you can relate it. If any time you are finding the integration, let's say 1, 2, 3, the limits are given like 1, 2, 3. The lower limit is 1, upper limit is 3. Okay. In this case, what will happen? Let's say fx is present here, some function of x, and your Dirac delta function is present in this way. Done. Now what will be the answer? Along with that Fourier transform concept, I am even completing this concept of Dirac delta function, which is involved in that Fourier transform question, so that if anybody is not familiar with it, they will be able to know about this concept as well. So what will be the answer in this case? Pradeep, I am considering it. I am just discussing that thing right now, so you have not missed anything. Prince will consider that point once again. See guys, here when you are comparing x minus 6 with 0, you are getting x is equal to 6. when you are getting x is equal to 6, is this existing within the limits 1, 2, 3? No, it is not between 1 and 3. So we can say that the answer will be 0. Okay, just be careful about it. Generally we consider this property within the limits minus infinity to plus infinity, and everything will exist there within the limits minus infinity to plus infinity, every value which we will get here. That's why we say, okay, the general property is this. But if that value is not existing within the limits, then you will say the answer is 0. Even some of the students have mentioned it in the comments that the answer is F6, whether it is not F6. Why? You have to focus on the limits as well. Pradeep and Timsley, is this clear? Is this clear to everyone? The answer will be 0 whenever the value of x is not existing within the limits. Done. Now let's go back to that Fourier transform question. So it was like, we know this thing. Okay, now the x is equal to 0 we will get from here. Clear? Now what I need to do, I can get this integration value with the property of Dirac delta function, that will be 1 upon root 2 pi, which was just a constant. Okay, 1 upon root 2 pi, I think it is not visible here, so let me just write this side. Clear? So it will be 1 upon root 2 pi, and the function, this is fx now, which is present with Dirac delta function. So we just need to write the value of the function at x is equal to 0. It will be e to the power iota s into zeros. That means e to the power 0, which will be 1. So I am going to get 1 upon root 2 pi as the final answer. If no formula is given, okay, in the question, or nothing about that is mentioned, or even with the options you are not getting some idea, use this one. This is as per your syllabus. Don't consider 1 upon 2 pi. If 1 upon 2 pi is given in the question, your answer will be 1 upon 2 pi. If nothing has been given, 1 upon root 2 pi. Okay, is that clear to everyone? Prince, you can check the session name, okay, and you will be able to know about the classical mechanics video or the session. Any doubt anybody is having till this point? If yes, please let me know. Okay, now my next question is, if we are going to find the Fourier transform of first order derivative of the Dirac delta function, that means delta dash x, what will be the value of the first order derivative of the Fourier transform if we are finding for the first order derivative of Dirac delta function? Anybody knows about that? Similarly, by using the Dirac delta function properties, you can find it out, but right now I am telling you directly what will be the value. That will be minus iota s upon root 2 pi. And even you can do it. How? I have told you one more property now, that if any time you want to find the Fourier transform of the first order derivative of any function for which you already know the Fourier transform, so you can directly find it out. It will be what? If we are taking fs, that was equal to 1 upon root 2 pi. Done. So it will be equal to minus iota s upon root 2 pi. That will be your final answer. And in the same way, even the order of differentiation will increase here, and you already know the Fourier transform of Dirac delta function itself. You will be able to get the final answer by using these properties. Is this clear to everyone till this point? Very good, Niloy. Thank you so much, Ranjit. Is this clear till this point? And if there is any doubt, you can mention, you can let me know about that. And even guys, there is a question which we can consider just now. Okay, just a second. Let me just give you one question related to Fourier transform, which we will do right now. And that's not a difficult question. That is going to be very easy, very simple question. Okay, I hope you all will be able to get it very easily. And everybody will try it. Okay. Ramchandra, basically this class has been planned just recently before the session. Okay, so it was not already planned. Clear? That's why you were not aware about the class. Okay, but in the Telegram channel I have shared the link about it, as I have just planned it. ठीक है. Pradeep, I will consider. And guys, tomorrow even I will consider the session here about 7:30. Yeah, about 7:30. Okay, and on the Telegram channel I will share the link. Clear? So in the evening at 7:30 we will have this session here tomorrow as well, and most probably regular we will have this session. Okay, but I will keep on informing you on the Telegram channel. Okay, so that you will easily be able to know about it, and a little early. Okay. So here are the options. Please try it once and let me know once you will get the answer. Pradeep, I will discuss. Let's wait for everyone to solve it once. Then I will start the discussion. Guys, let me know once you will get it done. Nazi, you can directly search it there, Mission Net Physics Exam, and you can write all the alphabets in capital letters. Okay, you will find it. So on Telegram, you can check it directly, because I may not be able to share the link here. Very good, Meenakshi. What about others, guys? Very good, Riya. Very good, Subramanyam. Arnav has mentioned the answer. Arnav, check it once more. Very good, Rakshit. Okay, two different options till now. Option C and option D from your side. Very good, Sahil. But that's very good, guys, that you have tried it. I will discuss so that if there is anyone who is having some doubt or difficulty in solving this question, they will be able to know about it. Very good, Kaushik. Okay, let's start the discussion now. So basically, guys, this exam, whether we are talking about the GATE physics exam or CSIR net physics exam, these exams are not just going to ask you, or they don't just expect you to memorize the formulae and to consider the points like just like that. No, these exams also want you to take the creative steps about the questions. It's not gonna be a direct Fourier transform based question, so it's not a direct question from there. Done. They have already provided you some information and they are asking you to find something. So when they give any expression to us, okay, that means it's gonna be related, okay, and whatever we want to find, there it can help us. But how? Let's talk about it. Do you all know that cos theta we can write in terms of exponential, and that is e to the power iota theta plus e to the power minus iota theta upon 2. We all know that. Clear? In this case, what will happen? In this case, guys, they already provided us the information about e to the power minus iota 2 pi VAT. I am saying that 2 pi VAT is nothing, it is just theta. Clear? Right now, just in general. So I know that f e to the power minus iota theta, f e to the power minus iota theta is gonna be equal to e to the power minus iota theta is gonna be equal to f omega plus a. If I am changing the power minus iota theta to plus iota theta, I am making it clear. So it will be what? Omega minus a. Is that okay? Because I have changed the sign of theta there. Or you can say the sign of a. Instead of taking it minus a here, now we are taking there plus a. Clear? So you can say the sign, negative sign, is for a itself. Clear? Next thing. After knowing about this thing, now let's try to put the theta we know. I have told you that theta I am considering 2 pi VAT. So I am just going to put the Fourier transform here. Clear? Because I want to know about the Fourier transform of cos theta, where theta is what? 2 pi VAT. So that same thing is present here. Done. So let's apply it at this place. What will be the answer? E to the power iota theta plus iota theta na. So what we will get? F omega minus A. F omega minus A. Done. And plus, what is the Fourier transform of this term? It will be F omega plus A. Clear? Upon 2. So 1 upon 2, let's take it here. And this is going to be our final answer. So you can see how easy it was to consider, and you can see it's matching with option C. So option C is correct. Any doubt anybody is having in this case? If yes, please let me know. Ramchandra, don't worry. Today in this session, whatever discussion I have done, if you will consider that much, you will have enough knowledge about this topic. Guys, I hope each and everything which we have discussed in today's session will be clear to all of you. Okay. Smriti, yes. Here we will have session about 7:30. Okay. Tomorrow as well. And I will keep on informing you about the upcoming classes. In these classes, guys, I will consider the tricks, concepts and questions together and from various subjects. It's not gonna be only about mathematical physics. Sometimes we will take classical mechanics, sometimes quantum, sometimes thermodynamics, sometimes nuclear, sometimes it's gonna be about solid state. Okay, so all subjects on different days. Clear? Don't miss the sessions near about 7:30. Okay, after our spatial class, like our spatial classes are going on 6 to 7 p.m. right now. Done. So after that we will have this session here. Clear? And I will keep on updating about it on the Telegram channel as well, that is Mission at Physics Exam. If you have not joined it, you can join, or the community, like in the community post here, even I will post it. Okay, once the session will get scheduled. So thank you so much everyone for joining this session. Also, as you all know, there are so many Unacademy Plus courses going on Unacademy Plus. So if you want to attend the more regular live classes of all the top educators, okay, we are having on Unacademy Plus. So you can take the Unacademy Plus subscription for that. And after taking the Unacademy Plus subscription, you will get so many benefits like weekly quizzes, doubt clearing sessions, mock tests, PDF of important notes will be available to you. Okay, and many important things which will surely help you to do the best preparation for your upcoming CSIR net physics exam. So if you want to take the Unacademy Plus subscription and if you want to attend the more regular live classes, you can take the Unacademy Plus subscription for that, and by using and by applying the referral code, that is Anjali Arora, as I have mentioned it here. So you just need to write it as it is, apply it, no space in between. Okay, so write it as it is, apply it and get the 10% discount in the total Unacademy Plus subscription amount. Clear? Also guys, after taking the subscription, you will be able to attend the live classes by all the top educators we are having on Unacademy Plus for your upcoming exam preparation. Clear? So thank you so much everyone for joining this session. Also, whatever discussion I have done in today's session regarding Fourier transform, if you are even going to cover this much part, you are covering the important points from this topic. Clear? So don't miss any of the points from this session. Cover it up first, and after that you can try to solve other different questions based on this topic. It will surely be helpful for you. Okay, and if you will have any doubt, you can let me know. Clear? Thank you so much everyone. One topic for 1 week on Pradeep, yeah, I will try to cover up most of the important points. Timsley, no, it's not at all tough. Keep on attending the sessions, you will find it easy. Okay, and guys, if you will attend my sessions, you will get like, oh, it's gonna be so easy. There is nothing like difficult. Clear? Thank you so much, Timsley. Even the quantum mechanics you will get easy, so don't worry about it. Thank you so much everyone for joining this session. Thank you.